So in this example, ladies and gentlemen, basically, again, as I mentioned, to go ahead and to do the antiderivative of this, define an antiderivative, we need to re-represent this as the power rule. So I'm going to re-represent this as x to the 1/2 dθx. And then now, to integrate, I'm just going to add 1 and add 1 over, and then do the same thing, 1/2 plus 1. Now, as a quick kind of rule of thumb, one thing that I cover kind of extensively, instead of adding 1, you guys agree with me, 1 is equivalent to 2 over 2, correct? So from now on in this class, or when I'm doing these rules, rather than showing adding 1, I'm just going to write whatever the denominator is over like the numerator, so therefore that's equivalent to 1. So instead of saying plus 1, I'm going to write plus 2 over 2, which you guys know is equivalent to 1, right? But it's much easier to do our math this way when you're doing plus 2 over 2 than actually adding the number 1, because then you have to get common denominators and so forth. So this is an easier way for us to apply that. So we have x to the 3/2 divided by 3/2. When you divide by a fraction, the same thing as multiplying by its reciprocal. So you could say it's 2/3 x to the 3/2. Don't forget to add your c, not an e.